The universe is silent. Not empty, not calm, just quiet in a way that presses against the mind. Beyond Earth's thin shield of air, signals move through darkness. Light fades. Radio waves stretch across centuries. Somewhere in that endless black, something unexpected happens. A spike where there should be noise. A shadow where there should be light, a pattern that should not exist. For decades, instruments have listened and watched. And again, the universe has answered with confusion instead of clarity. What are these things that break the rules we trust? And why do they keep appearing now? Astronomy was once simple. Look up, chart the stars, measure their motion. The sky felt orderly, distant, predictable. Then the tools changed. Metal dishes grew wider, mirrors grew larger. Sensors learned to see heat, radio waves, ancient light left over from the birth of everything. With each new way of seeing, the universe stopped behaving. Not slowly. Suddenly, signals appeared once and vanished forever. Stars dimmed without rhythm or reason. Perfect circles emerged, where chaos should rule. These were not theories, not guesses. They were measurements. Recorded, logged, verified. And they made no sense. At first, these discoveries seemed isolated.
Energy fluctuations
one strange
stabilize
signal
at this
here,
threshold.
one misbehaving star there, easy to
here?
dismiss, easy
Could that
to
affect
assume
the
error.
causality
The
loop?
universe is large. Mistakes happen. But the anomalies did not stop. They multiplied. Radio telescopes detected emissions so narrow, so precise, that nature itself seemed to hesitate. Light from distant stars fell away by massive fractions, then returned as if nothing had happened. Entire regions of space appeared almost empty, vast volumes where thousands of galaxies should exist, yet did not. And deeper still, in the oldest light ever observed, there were scars, cold regions imprinted on the afterglow of creation itself. This was no longer coincidence. Something was wrong, or something was incomplete. Space does not announce its secrets, it whispers them. Through static, through flickers, through absences. A signal appears for barely more than a minute, strong, focused, then gone. No repetition, no echo, just silence afterward, stretching across decades. If it were noise, it would return. If it were error, it would repeat. But it did neither. Somewhere in the depths of the galaxy, energy aligned itself into a single, narrow frequency, one tied to the most common element in existence, hydrogen. The universal signature. Then it vanished. No source identified. No cause confirmed. Only a question suspended in time. Elsewhere, light itself betrayed expectation. A star, ordinary by every known measure, began to dim, not gently, not predictably, massive drops, 15%. Then more, then even more. Too large for planets. Too irregular for rotation. Something vast passed in front of that distant sun again and again. Each time different, each time wrong. Dust was suggested, debris, catastrophe, yet the colors did not shift as dust should demand. Heat did not rise as destruction would require. The star remained calm. Only its light faltered, and it kept happening. Then came shapes the universe rarely allows. Perfect circles. Not drawn by hand, not imagined, observed. In radio light alone, immense rings appeared, centered on distant galaxies, each one larger than entire galactic systems, hollow, symmetrical, silent. Nature prefers chaos. Perfection is suspicious. These rings had no clear origin, no energetic engines, no visible violence. They simply existed, etched faintly into the radio sky, waiting for explanation that has yet to arrive. And far beyond individual stars and galaxies, something even more troubling emerged. Structures too large. On scales where the universe should smooth itself out, where matter should spread evenly, enormous arcs and rings of galaxies stretched across billions of light-years. Too large to form, too vast to survive. According to every calculation, gravity has not had enough time to build them. The universe should not allow such order on such scales. Yet there they were. Curved chains of galaxies bending across ancient space, defying one of the deepest assumptions of cosmology, that on the largest scales the universe is uniform. It may not be. And then there is emptiness. Not the normal emptiness between stars, but a void so large it swallows expectation. A region hundreds of millions of light-years wide, where galaxies are scarce. Where light travels uninterrupted for unimaginable distances. This emptiness began as a whisper in the early universe, a tiny imbalance. Over billions of years, gravity drained it further and further, until almost nothing remained. A cosmic absence. Even the galaxies trapped inside it seem altered. Isolated, unharassed, evolving alone in darkness. And behind it all, beneath everything, lies the oldest image of the universe itself. The first light. That ancient glow should be smooth, nearly perfect. But it is not. A vast cold region stains it, colder than theory predicts, larger than chance prefers. Light from the beginning of time passed through something, lost energy, returned, diminished. What did it cross? And why? Some explanations strain physics, others strain imagination, and none fully succeed. Even stars, those most studied of objects, refuse to behave. Some contain elements that should not exist. Radioactive atoms that decay too quickly to survive billions of years, yet their signatures persist. Something replenishes them, or something is misunderstood. And passing briefly through the solar system itself, an object arrived from elsewhere. Not bound to the sun. Not born here. It moved too fast. Shaped too strangely. Accelerated without visible cause. It did not linger. It never returned. Explosions too began to change. Brighter than supernovae. Faster, hotter, gone before explanations could catch up. And somewhere nearby, a star appeared almost too old. Its age brushing against the age of the universe itself, a contradiction written in starlight. Each of these discoveries stands alone. But together they form a pattern. The universe is not finished revealing itself. Every improvement in our instruments peels back another layer, and behind it is not comfort, but confusion. This is not failure. This is discovery. Because the most important moments in science begin with a sentence that feels uncomfortable to say. We do not know. And space keeps reminding us. The journey into these mysteries did not begin with answers. It began with instruments pushing past their limits. As telescopes grew more sensitive, space stopped behaving like a distant backdrop and started acting like a living system, not alive, but active, dynamic, full of motion and surprise. Radio antennas swept the sky night after night, collecting whispers from the dark. Most of it was noise, random, meaningless. The background murmur of the universe breathing. But hidden inside that noise were patterns so faint they almost escaped notice. When those patterns appeared, the first instinct was doubt. Check the calibration. Check the equipment. Check the sky again. Space does not forgive assumptions. Signals were logged and compared, frequencies measured, strengths plotted, positions traced across time. And slowly, uncomfortably, it became clear. Some signals did not belong to any known source. They did not drift like natural emissions. They did not smear across frequencies, as cosmic processes usually do. They arrived sharp, focused, brief. Then they were gone. The same sense of unease followed the first strange stars. Continuous monitoring revealed that starlight, once considered reliable and steady, could betray expectation. A star that should shine evenly instead faltered like a failing heartbeat. The light dropped, recovered, dropped again. No rhythm, no cycle, no warning. Each dip carried weight. Every percent of lost light meant something massive had crossed the star's face, yet nothing visible remained afterward. No glow, no heat, no debris trail screaming catastrophe. Just absence. As observations accumulated, the universe felt less like a clockwork machine and more like a puzzle missing its picture. Each new dataset added pieces, but the image refused to sharpen. Then came the radio sky. Where visible light showed galaxies and stars, radio waves revealed ghosts. Vast rings hovered around distant galaxies, invisible to ordinary sight. Perfect curves etched into nothingness. They were too clean, too symmetric. Natural chaos rarely leaves such tidy marks. No shock fronts were visible, no blazing jets, no obvious violence. And yet the rings existed, spanning distances that dwarfed entire galaxies. Silent structures broadcasting only in wavelengths the human eye would never see. The challenge grew heavier with scale. On the largest cosmic maps, where individual galaxies blur into statistical clouds, something bent the pattern. Instead of even distribution, matter curved, arcade, wrapped into colossal forms stretching billions of light-years. At such scales, the universe should forget its small details. Gravity should smooth everything out. Clumps should dissolve into uniformity. They did not. Instead, enormous features stood out like scars, too large to be coincidence, too organized to ignore. These were not nearby. They were ancient. The light revealing them began its journey when the universe was young, long before Earth existed, long before stars like the Sun were born. If these structures were real, then something fundamental about cosmic growth was missing from the story. And then there was the emptiness. Vast regions where the cosmic web thinned to almost nothing. Volumes of space so large that light could travel for hundreds of millions of years without brushing past a galaxy. According to averages, thousands of galaxies should have filled these regions. Instead, only a few lonely systems drifted inside. The universe had carved out holes, not by explosion, not by removal, but by slow neglect. Gravity, relentless and patient, had pulled matter away over billions of years, deepening these voids. Yet the sheer size of them pressed against the limits of theory. Too empty, too large, and the galaxies trapped inside them told a strange story of their own. Isolated systems grew differently. Star formation followed unfamiliar paths, shapes twisted without the usual gravitational harassment of neighbors. Even absence left fingerprints. Then attention turned to the oldest light of all, the faint microwave glow that fills the universe evenly in every direction. A relic from the moment space first became transparent, a near-perfect snapshot of the cosmos as it once was. Near-perfect. Because buried in that ancient light was a flaw, a region colder than expected, larger than chance alone could easily explain. Photons that should have arrived warmer did not. They lost energy somewhere along the way. Through what? Or why? Some suggested emptiness again. A massive void draining energy from passing light, but calculations refused to cooperate. The numbers fell short. The cold spot remained colder than it should. Each mystery raised the same problem. Not that explanations were impossible, but that none were complete. Stars held radioactive elements that should have vanished eons ago. Interstellar visitors accelerated without visible cause. Explosions burned brighter and faster than known physics comfortably allowed. The universe was not breaking laws. It was exposing gaps. And every gap pointed to the same challenge. Understanding depends on repetition. Science thrives on patterns. But many of these events were rare, singular, fleeting. A signal once heard. A visitor once seen. An explosion once caught before fading forever. There were no second chances. The universe did not pause for study. It continued on, indifferent to confusion. Light kept traveling. Matter kept evolving. And humanity was left staring at records of moments that would never repeat in exactly the same way again. This was the first true challenge. How do you understand something that refuses to return? How do you explain an event that leaves only one trace? The answer was patience. More instruments. More sky. More time. Every new telescope promised clarity, but also risk, because each new way of seeing the universe had already taught a hard lesson. When vision improves, certainty decreases. The deeper the view, the stranger the cosmos becomes. And somewhere ahead, waiting beyond current limits, more anomalies were already forming. Signals not yet detected, shadows not yet noticed, structures not yet mapped. The universe was not done surprising anyone. It was only beginning. Confusion deepened when patterns refused to stay isolated. What first looked like rare accidents began to echo each other. Signals appeared without warning. Stars dimmed without reason. Structures emerged without permission from theory. Each discovery alone could be questioned. Together, they demanded attention. Astronomers began to realize the problem was not equipment, it was expectation. The universe was not obligated to behave according to models built from limited experience. Those models were based on what had already been seen, not on everything that existed. And now, something new was pushing back. Consider the nature of cosmic signals. Space is loud in its own way. Pulsars beat like clocks. Quasars roar across billions of light years. Magnetars scream in brief bursts of radiation strong enough to distort Earth's atmosphere. These sources follow patterns. They repeat. They age. They leave fingerprints across wide bands of frequency. But some signals did not. They were narrow, focused, brief, almost deliberate. Natural processes tend to smear energy across ranges. Heat spreads, turbulence diffuses, chaos dominates, precision is rare. And yet precision appeared. When scientists searched for repetition, they found none. When they searched for nearby explanations, they came up empty. The sky stayed quiet where answers should have echoed. Elsewhere, light misbehaved in subtler ways. Stars are engines. Their physics is well tested. Pressure balances gravity. Fusion feeds light. Variations happen, but they follow rules. Variable stars pulse. Eclipsing systems dim on schedule. Stellar spots rotate in and out of view. The strange stars did none of this. Their light fell suddenly, unevenly, deeply, then returned as if untouched. No heat bloom followed. No infrared glow revealed dust warming in orbit. The color of the starlight barely changed. Something large was there. And then it was not. As explanations strained, attention shifted to environment. Maybe stars were not alone. Maybe they lived amid debris fields left by ancient disasters. Shattered worlds. Tidal remnants. Clouds thick enough to block light, yet cold enough to hide their presence. But even this required coincidence stacked upon coincidence. Too much mass, too little heat, too much irregularity. The answers remained just out of reach. The radio sky offered no comfort. Odd circles lingered in data like afterimages, perfect outlines floating around distant galaxies. Their scale was staggering. Hundreds of thousands of light years across, larger than galactic disks, larger than anything their quiet centers suggested they could create. If explosions made them, they were too neat. If jets shaped them, they were too symmetrical. No scars pointed back to a violent origin. No bright cause screamed energy release. They existed without narrative. At the largest scales, doubt turned into discomfort. Cosmology relies on assumptions that simplify the universe. That no direction is special. That no region is privileged. That on the biggest scales, randomness smooths everything out. Those assumptions had always worked. Until they didn't. When galaxies arranged themselves into enormous arcs and rings, far larger than gravity should permit, the math faltered. These were not nearby structures still forming. They were ancient, already frozen into place by the time their light reached Earth. If gravity built them, it had help. If chance arranged them, it was improbably generous. Either way, something was missing from the picture. The emptiness between galaxies told a quieter but equally troubling story. Voids were expected, they were part of the cosmic web, but some voids grew too large, too empty, too extreme. Simulations reproduced filaments and clusters with ease. Voids formed naturally, but pushing them to such vast scales required rare conditions. Conditions that seemed too specific to repeat so clearly. Yet they existed. And inside them, galaxies behaved differently. They formed stars without interruption. They evolved slowly, untouched by mergers or tidal stress. They were reminders that environment shapes destiny, even on cosmic scales. The oldest light of all remained the hardest to explain. The cosmic microwave background was supposed to be a triumph, a near-perfect confirmation of theory. Its uniformity supported the idea that the early universe was smooth and simple. Tiny fluctuations seeded everything that followed. But the cold region refused to blend in. Its size made it noticeable. Its depth made it troubling. Statistical flukes happen, but the universe only gets one roll of the dice. And this roll stood out. If it were chance, it was unlucky. If it was structure, it was unaccounted for. Then came matter that should not survive. In the atmospheres of certain stars, radioactive elements appeared again and again. Elements with lifetimes measured in millions of years, not billions. Long gone, according to nuclear physics. Yet their spectral lines were clear, stable, persistent. Either the stars were creating them, or something else was feeding them. Both possibilities demanded new physics. Even closer to home, surprise arrived from beyond the solar system. An object entered fast and left faster. Its path betrayed its origin. It was not bound to the sun. It belonged to another star, another system, another history. Its shape was wrong. Its motion was wrong. After passing the sun, it gained speed without visible propulsion. No tail, no cloud, no obvious source of thrust. Light itself seemed to push it. Radiation pressure, usually negligible, became relevant only if the object was thin. Extremely thin. Too thin to form easily by natural processes. Speculation followed, caution demanded restraint. But the questions lingered. And then the explosions. Brief, intense, blue hot, gone in weeks. They did not resemble supernovae. They rose too fast. They faded too quickly. Their energy escaped in ways models did not predict. They were births or deaths or collisions of something compact and extreme. Black holes, neutron stars, white dwarfs, perhaps combinations not yet fully imagined. Each detection added urgency. The universe was revealing classes of events never predicted, not variations, entirely new categories. By now, it was clear this was not a collection of curiosities. It was a pattern of disruption. Every scale was affected. From subatomic decay in stars to the arrangement of galaxies across billions of light years. Physics worked, but not completely. The rules held, but only within boundaries. Outside them, reality grew strange. This was not a failure of science. It was a sign of growth.
Steady.
Every time humanity believed it understood the universe, deeper observation proved otherwise. The more clearly space was seen, the less familiar it became. And the realization settled in quietly. These mysteries were not glitches. They were messages, not answers. Invitations. Invitations to look again, to listen longer, to accept that understanding is always provisional. Because somewhere beyond current sight, beyond current models, the universe was already preparing the next surprise. And it would not wait to be asked. The pressure to explain grew heavier as the anomalies piled up. Not because answers were expected quickly, but because silence, in science, is rarely comfortable. When observations refuse to align, every assumption comes under scrutiny. Astronomers began retracing foundations they once trusted without question. The equations still worked, the predictions still held most of the time, but the universe was revealing edge cases. And edge cases are where understanding either deepens or breaks. The first line of defense was refinement. More data, longer observations, wider coverage. If a signal appeared once, listen harder. If a star dimmed strangely, watch it continuously. If a structure seemed too large, map its surroundings with greater precision. But refinement brought clarity and discomfort in equal measure. The strange stars dimmed again. The radio circles remained. The cold spot held its shape. Nothing faded under scrutiny. Instead, explanations began to conflict with each other. Dust could explain color changes, but there were none. Gas could explain acceleration, but no gas was seen. Shock waves could explain radio shells, but no shock fronts appeared. Each theory solved one piece and broke another. This forced a difficult shift. Perhaps the problem was not missing causes. Perhaps it was missing context. Space is not uniform in experience. Conditions near stars differ from those between galaxies. Time stretches differently across cosmic history. Processes that are rare today may have been common when the universe was young. Some mysteries began to cluster around age. The largest structures appeared far away. The cold spot traced back to ancient light. The oldest stars behaved the strangest. This suggested the early universe may have left fingerprints still visible today. Imprints too subtle to notice before, too large to ignore now. The idea was unsettling. It meant that some assumptions baked into modern cosmology might only work locally, that simplicity emerges with time, not at birth. If true, then the universe was never meant to be smooth. It only learned to appear that way. At smaller scales, the tension took a different form. Nuclear physics is precise, decay rates are constants, half-lives do not negotiate, and yet stars carried elements that should have vanished long ago. To accept this, something had to give. Either the elements were being created in ways not yet understood, or matter behaved differently under stellar conditions, or observations were being misread in a systematic way. None of these options were easy. The deeper the investigation went, the more uncomfortable the implications became. Physics had always relied on universality, the same rules everywhere, the same constants across time and space. But what if that assumption was only mostly true? What if some constants drift? What if some processes awaken only under extreme isolation? What if the universe has modes it rarely enters, but never forgets? These ideas lived at the edges of respectability. They were not embraced, they were not dismissed, they waited. The interstellar visitor sharpened this discomfort. Here was an object from beyond the sun's influence, a messenger from another planetary system, a fragment shaped by conditions no telescope had yet seen directly. It did not behave like expectations, and expectations had no chance to adjust. By the time questions formed, it was gone. This revealed a deeper vulnerability. Some events are too fast, too rare, too fleeting. The universe does not slow down for understanding, it offers glimpses, not guarantees. This made the role of chance unavoidable. If a phenomenon appears once every century, or once every million years, then detection becomes luck, and luck is not a foundation science prefers. But the universe does not care what foundations feel comfortable. Explosions that burned brighter than supernovae forced another recalibration. These were not minor variations. They were faster, hotter, and shorter-lived than anything catalogued before. They rose like flares, and vanished before models could stabilize. Each detection arrived with urgency. Point telescopes now. Collect what light remains. Then silence. Their very existence implied that the death of stars is more diverse than once believed. That collapse and collision can follow pathways not yet mapped. That extreme physics still has chapters unwritten. And behind all of this, the age problem lingered. A star too old. Not impossibly so. Just enough to be troubling. Its light suggested it formed when the universe itself was barely awake. Earlier than should be comfortable. Earlier than models preferred. Adjustments were made, distances refined, compositions recalculated, yet the tension remained. The universe was not contradicting itself outright. It was whispering that the margins mattered, that the rare events, the isolated systems, the early moments, these were where understanding would either stretch or tear. This realization changed the tone of the search. The goal was no longer to force anomalies into existing boxes. It was to ask whether the boxes themselves were incomplete. History offered a warning. Every time physics believed itself nearly finished, reality intervened. Mercury's orbit, blackbody radiation, the constancy of light, the acceleration of cosmic expansion. Each began as a small discrepancy. Each ended in revolution. Now discrepancies were appearing everywhere. Not loudly, quietly. As signals in static, as shadows in starlight, as absences where matter should be. The universe was not shouting. It was testing attention. And the question was no longer whether these mysteries would reshape understanding. It was how much. Because somewhere among these anomalies, one of them was not just a curiosity. It was a fracture. And when it finally gave way, everything built upon it would have to change. There comes a moment in every search when accumulation turns into weight. Not curiosity, burden. By now the anomalies were no longer scattered. They overlapped in time, in scale, in implication. Each new observation did not simply add mystery, it narrowed the space where certainty could hide. The crisis was not a single event. It was realization. That the universe was speaking in contradictions. At the smallest scales, atoms decayed exactly as predicted. In laboratories, physics held firm. On Earth, constants behaved. But far from Earth, in stars isolated for billions of years, those same rules seemed flexible. Radioactive elements lingered where none should remain. Their signatures were sharp, unmistakable, not noise, not artifact. Repeated measurements confirmed them. Either matter was being remade, or time itself was behaving differently. Neither option was acceptable without consequence. At stellar scales, light itself became unreliable. A star dimmed deeply, then recovered, again and again. Not a failure, not death, a rhythm without pattern. No debris glowed. No heat betrayed motion. Something massive passed between star and observer, then vanished without trace. To explain it required invoking catastrophes that left no scars, or structures that produced no heat, or processes that had never been seen elsewhere. Each explanation solved the dimming, but broke something more fundamental. At galactic scales, the radio sky refused to cooperate. Perfect rings lingered in the data, immune to dismissal. They were not faint illusions. They grew clearer with better instruments. Larger surveys revealed more of them. Rare, but real. They demanded energy without engines, order without symmetry breaking, origins without aftermath. And then, beyond galaxies, beyond clusters, the universe itself bent expectation. Structures spanned distances too great for gravity to organize. Not barely too great, orders beyond comfort. Calculations insisted they should not exist. Observations insisted they did. This was the breaking point. Because cosmology depends on scale, the idea that beyond a certain distance the universe averages out, that no matter where you look the large picture stays the same. That assumption underpins everything: expansion rates, age estimates, the story of cosmic history. If it failed even slightly, the consequences rippled everywhere. The crisis deepened with emptiness. Vast voids where matter had been pulled away too efficiently, regions stripped so clean that simulations struggled to recreate them. Gravity had done its work too well. Or something else had helped. And behind it all, the oldest light in existence carried a blemish, a cold region imprinted when the universe was young and fragile. It was not subtle. It was not ignorable. Light lost energy crossing something, but that something was not enough, not dense enough, not empty enough. The numbers did not balance. This was the moment science fears most. When every explanation is partial. When certainty dissolves into probability. Some suggested coincidence. Enough rare events can cluster by chance. But chance does not explain consistency. It does not explain persistence. Others suggested unseen matter, fields, forces, components yet unnamed. Dark matter already filled the universe invisibly. Dark energy already drove expansion. Adding another unknown felt less shocking than admitting deeper error. But piling mysteries atop mysteries was not progress. Then came the visitors. Objects from outside the solar system, once hypothetical, became real. One passed through silently, indifferent to scrutiny. It accelerated without visible cause. Gravity alone could not explain it. Outgassing left no trace. Light itself became suspect. Radiation pressure, once negligible, suddenly mattered, but only if the object was thin, unnaturally thin. That implication hovered, uncomfortable and unresolved. And then the explosions. Fast, brilliant, brief. They appeared in distant galaxies like flashes of forbidden physics. Too energetic, too quick, gone before understanding could catch up. They were not supernovae. They were something else. Births of compact objects, deaths of stars in unfamiliar ways, collisions that physics had not yet categorized. Each event arrived without warning and left only fragments of data. This accumulation marked the crisis point. The realization that observation had outrun theory. That for the first time in generations, astronomers were mapping territory with no guide. This was not incremental confusion. It was structural. The universe was not contradicting laws outright. It was revealing where they stopped being sufficient. And sufficiency matters. Because every model rests on assumptions, simplifications, boundaries of applicability. And now, those boundaries were being crossed regularly. Not by one anomaly, by many. The question became unavoidable. Was this a collection of unrelated puzzles? Or evidence of a deeper framework still unseen? If the latter, then some future explanation would not merely solve one mystery, it would reorganize them all. But until then, uncertainty reigned. Funding proposals grew cautious, papers hedged conclusions, language softened, confidence narrowed. Not from fear, from respect. Because the universe had reached a point where it could no longer be forced into familiar shapes. This was the moment before change. The pause before revision. Every discipline experiences it, a quiet interval where data piles up, tension rises, and no one yet knows which idea will break first. Theories stood intact but strained. Observations stood firm but unanswered. And somewhere between them a turning point waited. Not an answer. A direction. Because the crisis was not that the universe was strange. It was that it was consistently strange. And consistency is never meaningless. The turning point did not arrive as a revelation. It arrived as restraint. After years of chasing explanations that collapsed under their own weight, a quieter approach emerged. Instead of asking what these mysteries were, attention shifted to how they were being seen. Not the universe itself, but the lens through which it was observed. Perspective mattered. The universe unfolds across timespans far longer than human intuition allows. Events that seem rare may be common when measured over billions of years. Phenomena that appear isolated may be connected by processes so slow they blur into invisibility. This reframing changed the tone of the search. Rather than forcing anomalies into known categories, scientists began to map relationships, not causes, patterns. Where did these events occur? When did they appear? What conditions surrounded them? Slowly, subtle alignments emerged. Many of the largest anomalies appeared at great distances. They belonged to the early universe, a time when matter was hotter, denser, less settled. When structures were forming rapidly, and physics had not yet cooled into familiarity. This suggested that some of what was being seen was not new behavior, but ancient behavior preserved, fossils of cosmic youth. If so, then modern models tuned to the present universe might be blind to earlier rules. This possibility opened space for hope. It meant the laws of physics might still hold, but only when applied within the right era. At smaller scales, environment became the key. Stars that behaved strangely often lived in isolation, far from dense clusters, far from gravitational disruption. Their solitude allowed slow processes to unfold uninterrupted for millions of years. In these quiet regions, small effects could accumulate. Dust could linger. Magnetic fields could sort elements. Radiation pressure could reshape matter, grain by grain. Nothing dramatic. Just patience. This explains some things. Not all, but enough to matter. Radioactive elements in stars might not be relics of creation, but products of ongoing low-level processes. processes too subtle to detect directly, but persistent enough to leave signatures. The idea was unsatisfying in its vagueness, but it was plausible. Similarly, dimming stars might not be hiding massive structures, but clouds of fine material shaped by forces not yet fully modeled, dust so cold and thin it evaded infrared detection, dust arranged not as disks but as drifting swarms. Irregular, temporary, enough to block light, not enough to glow. This did not solve the mystery, but it softened it. The radio circles too gained context. Rather than products of sudden explosions, they might be echoes, shock waves from ancient events, long faded, leaving behind shells of energized particles. Not violence. Aftermath. The centers of these rings were quiet now, but they may not always have been. Time erases clues. What remains is shape. At the largest scales, cosmology found its footing again, not through denial, but through nuance. The universe could be statistically uniform while still allowing rare extremes. Uniformity does not forbid structure. It only limits frequency. A few massive arcs do not break the rule, they test it. This reframing allowed models to stretch without snapping. Gravity alone might still sculpt the universe, given enough time and rare initial conditions. The voids too fit this picture, not violations but extremes. Places where early imbalances grew unchecked, where matter fled and never returned. The cold spot remained the most stubborn. But even here, perspective offered relief. If the early universe was not perfectly uniform, then rare imprints could survive. The cold spot might be one such imprint. A relic of a fluctuation slightly larger than average. Uncomfortable, but not impossible. The interstellar visitor resisted all attempts at domestication. Yet even here, humility prevailed. Planetary systems beyond the sun are diverse, some violent, some chaotic. Collisions could produce fragments unlike anything formed locally. Thin shards, flattened debris, rare but not forbidden. Radiation pressure could matter under the right conditions, especially for objects that traveled long distances, eroded by cosmic rays into unfamiliar forms. As for the fast explosions, time itself became the answer. Astronomy had been biased toward long-lived events, slow supernovae, persistent signals. Transients that vanished in days had often been missed entirely. Now that the sky was watched continuously, these events emerged, not because they were new, but because observation had finally caught up. They were not violations. They were blind spots revealed. This realization brought cautious optimism. Not every mystery needed a new law of physics. Some required better coverage, better patience, better humility. But optimism came with limits. Some anomalies refused to soften. Some contradictions remained sharp. The age of the oldest stars still pressed against the age of the universe. The precision of certain signals still defied natural spread. And no reframing could explain everything. This was the true turning point. Not resolution, but balance. A recognition that some mysteries would yield to refinement, others would demand revision, and a few might require something entirely new. Science does not advance by comfort. It advances by tension, held just long enough to break into insight. The universe had not offered answers yet, but it had offered direction. Look deeper in time. Look wider in space. Look longer, without assuming familiarity. The path forward was clear, even if the destination was not. Some mysteries would fade quietly. Others would grow louder. And among them, one would eventually force a change so profound, it would redraw the map of understanding. For now, the universe waited. And so did those listening. Momentum returned, not as certainty, but as resolve. The questions had not vanished, they had sharpened. With perspective regained, attention shifted to the edges, the places where explanations still failed, the anomalies that refused to soften under reframing. These were the pressure points, the places where the next breakthrough would emerge, or where understanding would finally fracture. The universe does not yield evenly. It yields where it is weakest. One such point was precision. Natural processes smear energy, They blur signals across space and frequency. Yet some observations remained unnervingly exact. Narrow radio emissions, sharp spectral lines, clean transitions where noise should dominate. These were not common, but they were real. Each demanded a source capable of restraint, something that could hold energy in tight channels over immense distances. That kind of control was rare in nature. Another pressure point was scale. The largest cosmic structures still hovered at the boundary of plausibility. Even when models stretched, they strained. Initial conditions had to be carefully tuned. Early density fluctuations had to align just right. Possible, but unlikely. And improbability, repeated, becomes discomfort. The cold imprint in ancient light also refused to fade. Statistical arguments dulled its edge but did not erase it. The probability remained small enough to unsettle. And then there was time. Time pressed hardest on the oldest stars. Their ages remained stubborn. Measurements improved. Errors shrank. The numbers did not retreat. The stars insisted on their antiquity. This was dangerous territory. Age underpins cosmology. The timeline of the universe connects expansion, structure formation, and cosmic history into a single narrative. If that timeline bent, everything else followed. At smaller scales, unexplained behavior continued to surface. Not in one place, but everywhere. As surveys expanded, the universe revealed variety beyond catalogue. Not chaos. Diversity. Stars with unusual chemistries. Galaxies with unexpected radio halos. Transient events with no clear lineage. This diversity hinted at a deeper truth. That the universe is not governed by a single pathway, but by many. That rare conditions produce rare outcomes. That the cosmos is more like an ecosystem than a machine. Complex. Adaptive. Unforgiving of oversimplification. This reframing allowed something new to emerge. A recognition that understanding might not come from one grand theory, but from layering. From accepting that different regimes obey the same laws in different ways. Gravity still ruled. Fusion still burned. Light still traveled at its limit. But context shaped outcome. Yet even this elegant picture left one question unresolved. Why now? Why were so many anomalies being discovered in the same era? The universe had not suddenly changed, but human observation had. Continuous monitoring. Wide-field surveys. Multi-wavelength coverage. The sky was being watched as never before. This was the climax of detection. For the first time, humanity was not just glimpsing events, it was catching them as they happened. Signals in real time. Transients before they faded. Patterns before they dissolved into noise. The universe had always been this strange. It was only now being seen clearly. This realization carried weight. It meant the current generation stood at a threshold, not of answers but of awareness. The cosmos was revealing its full complexity, and the cost of that revelation was uncertainty. And uncertainty demands courage. Because once the old simplicity is gone, it cannot be reclaimed. Models grow heavier, explanations multiply, comfort fades. But knowledge deepens. This was the emotional peak, not a discovery but an acceptance, that the universe is not obligated to be neat, that it does not compress into human-friendly rules. The sky had become a living archive. Every anomaly a record of conditions that once existed. Every signal a trace of something that happened long before Earth formed. Some mysteries would resolve quietly. Some would resist for generations. But one thing was now clear. The era of assuming completeness was over. The universe had outgrown the boxes built for it. And somewhere within this growing complexity, a deeper order waited. Not obvious, not simple, but real. The climax was not an answer. It was a turning of attention. From certainty to exploration. From explanation to listening. The universe was speaking more clearly than ever before. The challenge now was to hear it without forcing it to say what was already believed. Understanding does not arrive all at once. It settles. After the surge of discovery and doubt, a quieter phase followed, one where the universe was no longer treated as a puzzle demanding immediate resolution, but as a landscape to be mapped slowly. The urgency softened. The questions remained. This was the resolution phase, not of answers, but of consequences. The first consequence was humility. Models were rewritten with margins. Predictions carried uncertainty openly. Confidence became conditional. Not weaker, but more honest. The universe had demonstrated that precision without context was fragile. The second consequence was patience. Long-term monitoring replaced short campaigns. Instead of chasing rare events, astronomers waited for them. The sky was no longer sampled, it was watched. Signals once thought singular began to gain companions. Not identical, but similar enough to suggest families. Dimming stars appeared elsewhere. Fast transients reoccurred. Interstellar visitors were no longer unthinkable. Rarity began to feel less lonely. The radio sky, once quiet and confusing, started to reveal structure. More circles emerged, faint but consistent. Their distribution hinted at age and environment. Not random, not uniform. Patterns were forming. At cosmic scales, the largest structures were folded back into the narrative. Not as violations, but as stress tests. They marked the limits of current models, showing where refinement was needed. The cosmological principle survived, but thinner. Less absolute, more statistical. Emptiness, once unsettling, became informative. Voids were recognized as laboratories. Places where gravity's absence revealed its influence elsewhere. The cold imprint in ancient light remained unresolved, but its role changed. It was no longer a threat to theory, but a reminder that the early universe was not perfectly smooth, that randomness had left scars. Time softened its edge. Even the oldest stars began to feel less paradoxical, not because their ages changed, but because understanding of early star formation improved. The first generations may have formed faster than once believed. The window between creation and complexity may have been narrower. The universe, it seemed, wasted little time. At smaller scales, exotic stellar chemistry found context. Magnetic fields, radiation sorting, long isolation. Together, these slow forces could sculpt atmospheres over immense spans of time. Nothing dramatic, just persistence. Interstellar objects became symbols rather than threats, proof that planetary systems eject debris freely. That the galaxy is filled with wandering fragments, each carrying history from elsewhere. Some would look familiar, some would not. And the fast explosions found a name. Not a full explanation, but a place in classification. They were recognized as a new population. Events that had always occurred, but had only just entered awareness. The resolution was incomplete, but meaningful. What once felt like chaos began to look like complexity. What felt like contradiction began to resemble depth. The universe had not broken. Understanding had expanded. This phase did not end the story, it prepared it. It created space for future insight, without demanding it immediately. Because resolution in science is rarely final, it is provisional, a moment of balance before the next wave of discovery. And that wave was already forming. New instruments were coming online, wider surveys, deeper sensitivity, faster response. The sky would soon be watched with even greater attention. More anomalies would appear. More patterns would emerge. The universe had revealed that it was richer than expected. And once that truth is seen, it cannot be unseen. This was the consequence of discovery. Not comfort. Perspective. The cosmos was no longer a collection of solved problems. It was a living record of processes unfolding across time and scale beyond easy comprehension. And humanity had learned something essential. That not knowing is not failure. It is position. A position at the edge of understanding, where questions are clearer than answers, and curiosity outweighs certainty. The resolution was not an ending. It was a settling breath. Before the story widened again, the meaning did not arrive with noise. It arrived quietly. After the turbulence of discovery and the slow settling of understanding, something deeper remained. Not an explanation, but a feeling. A realization shaped by distance, time, and humility. The universe was not revealing its secrets to impress. It was revealing them because observation had finally caught up. Across billions of years, stars had lived and died without witnesses. Galaxies had collided. Voids had emptied, signals had crossed the darkness alone, none of it waited for attention, none of it required interpretation. And yet, here it was. Entering awareness. That carried weight. Every strange discovery became a reminder of scale, that human history occupies a thin slice of cosmic time. That civilizations rise and fall, while light from distant galaxies is still in transit. The mysteries were not failures of knowledge. They were markers of perspective. A radio signal lasting seconds had become a symbol spanning generations. A dimming star had turned patience into a discipline. Ancient light carried scars from the universe's youth, still visible after everything else had changed. These were not just anomalies. They were messages about endurance. The universe survives without explanation. It evolves without permission. It does not simplify itself for observers. And that truth reshapes meaning. Progress is not linear. Understanding does not arrive cleanly. It accumulates through tension, contradiction, and doubt. Certainty fades. Curiosity remains. There is a quiet courage in continuing to look when answers do not come easily. In returning to the same stars, the same signals, the same data, knowing they may never resolve fully. That persistence is the legacy. Not mastery of the cosmos, but participation in it. Each generation inherits unanswered questions, not as burdens, but as invitations. To refine tools, to sharpen thought, to listen more carefully. The universe does not rush. Neither can understanding. Some mysteries will resolve with a new instrument. Some will fall to better models. Others may linger beyond any single lifetime, waiting for minds not yet born. That does not diminish their value. It enhances it. Because meaning in exploration is not found only in arrival, it is found in motion, in the willingness to step into uncertainty and remain there. The night sky is not empty. It is layered with history. Every point of light is a record, every anomaly a trace of conditions that once existed. Together they form a story still being written. And humanity, small and fragile, has learned to read fragments of it. That alone is extraordinary. The universe remains vast. Understanding remains incomplete. But the search continues. Not driven by fear. Not driven by answers. Driven by wonder. A quiet, enduring wonder that looks into the darkness and chooses, again and again, to keep listening. The signal appears without warning. 72 seconds. Then silence. A star dims, not once, not twice, but again and again without rhythm or mercy. Perfect circles glow in radio light, surrounding distant galaxies like scars no one remembers making. Structures stretch across billions of light years, too large to exist, yet impossible to ignore. A region of space opens its arms and holds almost nothing. Hundreds of millions of light years wide. Empty. Ancient light carries a cold imprint, a shadow left when the universe was young, still visible after everything else has changed. A star shines with elements that should have vanished long before life on Earth began. Something from another star system cuts through the solar system once, then disappears forever. An explosion ignites brighter than a supernova, faster than theory allows, and fades before understanding arrives. And somewhere nearby a star quietly insists it is older than time itself. These are not stories from imagination. They are observations. Measured. Recorded. Verified. Each one bends expectation. Each one strains explanation. Together they form a pattern of disruption. The universe, long thought mapped and categorized, reveals cracks, not failures, but openings. Places where new understanding waits. This journey moves from radiostatic to dying stars, from ancient light to interstellar messengers, from the largest structures ever observed to the smallest fluctuations left at the beginning of time. Nothing here is hypothetical. Nothing here is comfortable. Every discovery raises a question that does not settle easily. What sends a signal once and never again? What blocks a star without revealing itself? What draws circles across the radio sky? What allows matter to gather beyond known limits? What empties space so completely? What scars the oldest light? What forges elements where they should not exist? What travels between stars? What explodes too fast to name? What survives longer than the universe itself? This is not a search for answers. It is an encounter with mystery. An exploration of the moments when observation outruns theory, when certainty fractures and curiosity takes over. Each chapter reveals a universe that refuses to be simple, a cosmos that does not align neatly with expectation. And through it all, one truth remains. The more clearly the universe is observed, the stranger it becomes. What follows is not a resolution. It is an invitation to look deeper, to listen longer, to accept that the unknown is not the edge of knowledge, but its beginning. The universe is speaking. These are the moments when it speaks the loudest. The strange things discovered in space share hidden details that often go unnoticed. Details that deepen the mystery rather than resolve it. The narrow radio frequency of the unexplained signal sits at a natural cosmic landmark. Hydrogen fills the universe, and that frequency is quiet, almost deliberately so. Astronomers call it a cosmic listening channel. That alone makes the detection unforgettable. The dimming star does something no other known star does. Its light drops are not just deep, they are asymmetric. Some dips are sharp, others are smooth. That suggests multiple objects or structures, not one. Whatever orbits that star is not uniform. The giant radio circles are invisible to the human eye. Even the most powerful optical telescopes see nothing at their edges. Only radio waves reveal them, meaning the energy involved is ancient, diffuse, and stretched thin by time. The largest cosmic structures appear aligned in ways that hint at early universe processes. If confirmed, they may preserve information from the first few moments after the Big Bang, long before galaxies existed. The Great Void is not silent. The few galaxies inside it show intense internal activity. Isolation may allow gas to collapse inward instead of being stripped away, creating unexpected bursts of star formation. The cold imprint in ancient light is colder than surrounding regions by a margin that exceeds most predicted fluctuations. Even small deviations in the early universe become enormous when stretched across billions of years. The star containing radioactive elements forces physicists to consider that nuclear reactions may behave differently under extreme magnetic fields. Some stars possess fields millions of times stronger than anything on Earth. The interstellar visitor rotated chaotically. Its tumbling motion did not stabilize, even after passing the Sun. That suggests its internal structure was uneven, fractured, or layered in unfamiliar ways. The fast blue explosions release more energy in days than the Sun will emit in its entire lifetime, yet they leave almost nothing behind, no lingering glow. No clear remnant, just absence. The ancient star with the impossible age is moving unusually fast through the galaxy. Its orbit suggests it formed in a region long since scattered or destroyed, preserving a record of the Milky Way's earliest years. Every one of these discoveries shares a quiet truth. None were predicted, none was searched for directly, they were found while looking for something else. That is how the universe reveals itself. Not on command. But when attention is paid, the universe does not announce its secrets. It leaves traces. A brief signal. A fading star. A silent void. Each one is small on its own, easy to dismiss, easy to postpone, but together, they form a quiet message, written across time and distance. A message that says understanding is never finished. That certainty is always temporary. For centuries, the night sky was a backdrop, fixed, decorative, familiar. Then it became a map, then a machine, then a history book written in light. Now it is something else. It is a conversation still in progress. Every strange discovery reminds us that the universe is not static, not solved, not neatly contained within equations and models. It is active, evolving, layered with events that happened long before Earth existed and will continue long after it is gone. The unanswered questions are not flaws. They are features. They are proof that curiosity still has somewhere to go, that exploration still matters, that there are frontiers left, not on distant planets alone, but in understanding itself. The strange things discovered in space are not warnings. They are invitations. Invitations to look longer at the sky, to listen more carefully to silence, to accept that wonder does not fade with knowledge, it grows. Some mysteries will resolve quietly, others will resist explanation for generations. A few may never fully yield, and that is enough. Because the value of exploration is not measured only by answers, it is measured by perspective. By the realization that humanity is small but capable, brief but aware. Light that began its journey billions of years ago ends its path in human eyes and instruments. That connection alone is extraordinary. The universe continues to expand. So does understanding. And somewhere beyond the reach of current instruments, new anomalies are already waiting, not to confuse, but to remind that the cosmos is vast, that knowledge is unfinished, that wonder is permanent. If this story moved you, don't forget to like, share, and subscribe to Cosmic Curiosity, where we explore the universe through the eyes of those brave enough to venture into the unknown. The cosmos is vast, but every story matters. See you among the stars. Beyond the quiet ending, the universe does not stop. It continues. After reflection comes expansion, not of answers but of reach. The sky grows wider as instruments sharpen. What once appeared as noise becomes structure. What once felt isolated begins to connect. This next phase belongs to awareness. The night is no longer just observed, it is monitored. Every flicker recorded. Every transient caught before it fades. The universe is being watched in real time, and that changes everything. Events that once slipped past unnoticed now leave fingerprints. Patterns begin to emerge not because they are simple, but because repetition brings clarity. The strange is no longer rare. It is catalogued. Dimming stars are compared across thousands of systems. Radio anomalies are traced through archives stretching decades. Explosions are grouped not by brightness alone, but by speed, temperature, and aftermath. The cosmos becomes less like a collection of isolated mysteries, and more like a network of behaviors. Still complex. Still unfinished. But no longer alone. The universe reveals itself gradually, not through grand declarations, but through accumulation, one data point added to another. One anomaly placed beside its cousin. Over time, edges soften, not because mystery disappears, but because context grows. This phase is subtle, less dramatic, but essential. It is where confusion turns into classification, where disbelief gives way to curiosity, where questions are refined instead of multiplied. Yet even here, limits remain. Some signals will never repeat. Some stars will never fully explain themselves. Some structures will resist clean interpretation. And that resistance matters. Because it reminds us that the universe is not designed to be solved quickly, or easily, or completely. It unfolds on timescales that dwarf civilizations. Human understanding must adapt to that pace.
What about the localized
This era is not about conquering mystery. It is about coexisting with it, learning when to press forward, learning when to wait. The tools improve, sensitivity increases. The sky becomes richer, but restraint grows alongside capability. Not every anomaly demands immediate explanation. Some require time. The greatest discoveries ahead may not come from forcing answers, but from noticing what persists. Patterns that remain after noise fades. Behaviors that repeat across environments. Structures that appear where none were expected. The universe leaves clues, but never instructions. And so the story continues not as a race, but as a vigil. Eyes on the sky. Instruments listening. Minds open. The strange things discovered in space are no longer surprises alone. They are signals of depth, evidence that the cosmos operates with more variation than once believed. That variation is not chaos. It is richness. A richness that demands patience, imagination, and humility. This chapter does not close questions, it reframes them. It teaches that mystery is not an obstacle, but a companion, one that keeps exploration honest. The universe remains vast. Human understanding remains partial. But the connection grows stronger. Light continues to arrive. Signals continue to cross the void. And somewhere beyond current limits, new anomalies wait quietly. Not to shock, but to expand what is possible to know. The journey is far from over. The deeper the search goes, the quieter it becomes. Discovery is often imagined as sudden revelation, a moment of clarity, a breakthrough that reshapes everything at once. But in truth, most understanding arrives slowly, in fragments, in whispers carried across years of observation. This stage of the journey is not loud. It is deliberate. The universe is no longer approached as a problem to be solved, but as a system to be respected. One shaped by timescales far beyond instinct. One that unfolds without regard for urgency. Here, attention shifts from spectacle to persistence. Not the brightest explosion, not the rarest signal, but the behaviors that endure. Patterns that repeat quietly across different regions of space. Subtle correlations between phenomena once thought unrelated. The same types of anomalies appearing in distant systems, separated by billions of light years, yet echoing one another in form. This is where understanding begins to deepen. Not by erasing mystery, but by framing it. A dimming star is no longer a singular oddity. It becomes one expression of circumstellar complexity. Dust, debris, magnetic forces, time. A radio circle is no longer an impossible shape. It becomes a remnant of energy, expanded and thinned, until only radio waves remain. Even the largest structures begin to feel less threatening. Not because they shrink, but because context grows around them. The universe starts to feel older, more layered. Every anomaly carries history. A record of conditions that existed once, briefly, and left marks that still persist. This realization changes how questions are asked. Instead of asking why something exists, the focus shifts to when. Instead of what caused it, attention turns to what conditions allowed it. The universe becomes a timeline rather than a machine. In this view, extremes are expected, rare alignments, unusual environments. Long chains of coincidence stretched across billions of years. Unlikely does not mean impossible. It means informative. And still, there are moments when that calm fractures. When a new signal appears without precedent. When a transient defies every known category. When data refuses to align. These moments remind us that humility must remain active, that no framework is final, that understanding is provisional by nature. The cosmos tolerates no arrogance. It does not reward certainty. It responds only to attention. This phase of exploration demands restraint. The discipline to say not yet. The courage to leave questions open. The patience to let years of observation accumulate before drawing conclusions. This is not indecision. It is maturity. Human curiosity has learned that rushing explanation can blind insight, that forcing answers can distort truth. So the search slows. That it does not stop. Telescopes continue to scan. Data continues to arrive, quietly, constantly. And with each passing year, the universe reveals a little more of its character. Not a final truth, but a direction. It becomes clear that strangeness is not an exception, it is a feature of scale. The larger the canvas, the more room for variation. Stars differ. Galaxies differ. Regions of space evolve under different pressures, histories, and constraints. Uniformity exists only in approximation. The deeper reality is diversity shaped by time. This understanding reshapes expectation. Instead of being surprised by anomalies, they are anticipated. Not predicted in detail, but accepted as inevitable outcomes of a vast system operating across immense spans. The universe is not tuned for simplicity. It is tuned for persistence. That persistence expresses itself in many forms, some gentle, some violent, some fleeting, some enduring. And within that persistence lies meaning. Not meaning imposed. Meaning observed. A recognition that complexity does not require intention. That beauty does not require explanation, that mystery does not require resolution to be valuable. The night sky, once distant, begins to feel intimate. Not because it is understood, but because it is familiar in its refusal to conform. The stars do not answer. They respond. They respond to attention with data, to patience with patterns, to humility with access. And in that exchange, something changes. The universe stops being a backdrop. It becomes a partner in inquiry. Not guiding, not instructing, but revealing itself slowly, on its own terms. This chapter does not promise clarity. It offers continuity. The knowledge that the search is sustainable, that curiosity can endure without closure, that exploration does not require an end to be meaningful. The cosmos remains vast. The questions remain open. And the silence between discoveries is no longer empty. It is full of waiting. The waiting teaches something essential. Not every truth arrives with evidence gathered quickly. Some reveal themselves only after long silence, after patterns repeat enough times to be undeniable. In that silence, understanding matures. This phase is about inheritance. Knowledge does not belong to one moment, it moves forward through generations. Each discovery handed off unfinished, marked with uncertainty, waiting for sharper eyes and steadier tools. The universe rewards continuity. What could not be explained once becomes clearer decades later. Signals dismissed as noise gain meaning when revisited with new context. Data archived patiently becomes revelation when viewed through a different lens. Nothing is wasted. The sky remembers. Light recorded years ago still carries information. Radio waves captured in forgotten surveys still contain structure. The universe does not expire, it accumulates. And so does understanding. This is where responsibility enters the story, the responsibility to preserve data, to document uncertainty, to resist premature conclusions. Because future insight depends on present restraint. The strange things discovered in space are not puzzles meant to be solved immediately. They are markers placed along a timeline longer than any human career. Each generation moves the marker slightly. Rarely does one remove it entirely. This is not limitation. It is design. The universe unfolds slowly enough that no single era can claim ownership of truth. Every age contributes fragments. Every observer leaves something behind. And that collective effort matters. It is why the unknown persists without frustration, why questions endure without urgency, why mystery remains fertile instead of exhausting. The cosmos does not demand conclusions. It invites stewardship. To observe carefully. To record honestly. To leave space for reinterpretation. This approach reshapes ambition. Success is no longer measured by solving everything. It is measured by clarity gained, by assumptions refined, by errors reduced. Progress becomes quieter, but deeper. The universe does not need to be understood completely to be respected. Its scale alone demands humility. Its longevity ensures patience. And within that patience, something profound happens. Curiosity stabilizes. It stops chasing spectacle and begins seeking coherence. It learns to value consistency over drama. The strange becomes familiar. Not explained, but accepted. This acceptance does not end wonder. It protects it. Because wonder thrives not on answers but on possibility. The cosmos remains open-ended. Every discovery expands the boundary of what is known, while revealing how much remains unseen. That boundary is not fixed. It moves outward with every generation. And in that movement lies purpose, not the purpose of conquest, not control, but participation. Humanity does not stand apart from the universe, it is part of its unfolding. A brief, conscious phase within a much longer story. The strange things discovered in space are not anomalies interrupting that story, they are chapters within it. Some readable now, some waiting. And as long as attention remains, as long as observation continues, the story does not end. It simply deepens. The story does not conclude with certainty. It concludes with perspective. After all the signals, the stars, the voids, and the structures that should not exist, one truth remains steady: the universe is not finished revealing itself. Not to science, not to humanity. What has been discovered so far is not a final map, it is a shoreline, a boundary where understanding meets vastness. Beyond it, the darkness is not empty, it is simply unexplored. The strange things found in space are not errors in reality, they are reminders of scale, of time, of how young human knowledge still is. Every anomaly marks a place where curiosity reached farther than explanation. Every unanswered question shows that observation is ahead of certainty. That is not failure, that is progress. The universe has existed for nearly 14 billion years. Civilizations, languages, and entire histories rise and vanish in the time it takes light to cross a single galaxy. Against that backdrop, confusion is natural. And yet, understanding grows. Slowly. Patiently. Each generation adds a layer, better instruments, sharper models, deeper humility. The universe does not resist being known, it simply does not hurry. The stars will continue to shine with unexpected chemistry. Signals will cross the void without explanation. Structures will challenge assumptions. Light from the beginning of time will keep arriving, carrying stories from an era beyond memory. And humanity will continue to listen. Not because answers are guaranteed, but because wonder is. The act of looking outward changes how inward questions are understood. The vastness reframes urgency, the silence teaches patience, the unknown restores balance. In a universe this large, certainty is rare. But meaning does not require certainty, it requires attention. The strange things discovered in space remind us that existence is not obligated to be simple. That reality can be elegant and confusing at the same time. That beauty does not always resolve into explanation. And that is enough. Because exploration is not about control, it is about relationship, a dialogue between observer and cosmos, one shaped by light, time, and curiosity. The night sky will never be fully tamed by knowledge, nor should it be. Its power lies in remaining larger than comprehension. As long as questions persist, the search continues. As long as the search continues, meaning remains alive. Somewhere beyond the limits of current instruments, new mysteries are already unfolding. Signals are traveling. Stars are changing. Structures are forming. They do not wait to be noticed. But when they are, they will matter. The universe is strange. Not because it defies understanding, but because understanding is still becoming. And humanity, small but aware, stands within that becoming, looking outward, listening carefully.